So as we are getting close to beginning our study of limits and calculus, we're going to be talking about tangent lines quite a lot. So because of that, I wanted to do a brief review of lines in general, so how to find their equations, what the slope means, etc. So that's the purpose of this video. So one of the most important features of a line is the slope. This represents the steepness of the line, and it tells you how one variable changes with respect to another. So lines and every equation that we're going to deal with in this class actually has two variables. So usually an x and a y, but it could be others. So this tells you how one variable changes depending on how the independent variable changes. So let me just draw a random line here. Okay, so notice that all I needed was 2 points. 2 points determine a line. So if you have 2 points, that's enough to get your line. So here's our line L. Okay, I actually found 3 points on this line. Now, how would we find the slope? So we talk about slope as steepness. So what it is how we get from one point to another. Okay, so the amount that we increase or decrease is called the rise, and the amount that we move over is called the run. So for our slope, we often say it's the change in the y values divided by the change in the x values. Okay, and this, another way you often say that is the rise divided by the run. So notice that I used 2 points on here, and I just went from one to the other. It doesn't matter what 2 points you do, the ratio will be the same no matter what. So the slope is not dependent on what choice of points you use. So our official definition, the slope is a line. The slope of a line is the vertical change, so the rise, over the horizontal change, the run, as we travel along. So we take any 2 points on the line. So I'm going to take x1, y1, and x2, y2. So those are my 2 random points. So the slope is going to be the difference in the y values, so y2 minus y1, over the difference in the x values, so x2 minus x1. Now, it doesn't matter which order you take the points, so which one you call 1 and which one you call 2, but what does matter is that the points match up. Okay, so you see the 2's are above each other and the 1's are above each other. So you do want to be careful that you match them up like that. But other than that, it doesn't matter which order you take them in. Okay, so that's our equation for the slope. And again, you might want to remember that it's the rise over the run. So a couple of notes. If m, so we normally call m the slope, if m is positive, then we move up to the right. Okay, and if m is negative, then we move down to the right. Or you could say up to the left. Okay, and here instead of up to the right, you could say down to the left. Would be the same as well. So also, the bigger the absolute value of m is, the steeper the line. So the closer that m is to 0, the less steep it will be. So let's just compute some slopes here. So we have these pairs of points. So let's say that this first point is x1, y1, and then we have x2, y2. Okay, so then m is going to be y2, so the 5 minus the 6 over the negative 4 minus the 7. Okay, so again, be careful, the 5 and the -4 were a pair, and the 6 and the 7 were a pair. Okay, so then this is going to be -1 over -11, which is 1 over 11 would be our slope. Let's try another one. So I'm going to label them the same way. So it's going to be -3 minus -3 over -2 minus 5. So this is -3 plus 3 over -2 minus 5. So I have 0 over -7. Okay, that's not a problem. Okay, that's 0. So here our slope is 0. So when the slope is 0, it means that, so remember it's rise over run. A fraction is equal to 0 when the top is 0. So it means the rise is 0. So we actually have a horizontal line when we get a slope of 0. Okay, last one. So again, I'm going to label it in the same way. So -4, okay, I did it backwards. Not that it matters, but so 1 minus -4 over 2 minus 2. So here I have 5 over 0. Now this is a problem. So we're not allowed to divide by 0. Okay, so this slope doesn't actually exist. And notice that the x-coordinates are the same. So if you were to sketch this, so we have a point down at 2, -4, and a point at 2, 1. If we connect those, we actually get a vertical line. Okay, so when you get a slope that doesn't exist, this is a vertical line. Okay, it actually has to be x equals 2. Okay, so now let's talk about equations for lines. So the most common way to write the equation is in slope-intercept form. So this is when you know the slope m and you know the y-intercept b. Okay, so this actually means that it has the point 0, b. So when x is 0, the y value is b. Then your equation, and I'm sure you all remember this because this is the one everyone always remembers, is y equals mx plus b. Okay, so this is in slope-intercept form. So let's do an example of using this. So we want the equation where we have x-intercept 4 and y-intercept 6. So x-intercept 4 means that our line, -4, our line goes through the point -4, 0. The y-intercept of 6 means that we have the point 0 and 6. So the first thing that we want to do is find the slope of these two. So I'm going to have 6 minus 0 over 0 minus -4. So this is going to be 6 over 4, or in reduced terms, 3 over 2. So that's our slope, and we already know our y-intercept, so that means our b value is 6. So our equation in slope-intercept form is going to be y equals 3 over 2x plus 6. Often, we don't have access to the y-intercept point, so we might have a different point. Okay, so when we make the equation of a line, we either need 2 points or the slope and a point. And if we have 2 points, then we have to find the slope first. So often we don't have the y-intercept. So in these cases, it's useful to use what we call the point-slope form. Okay, so if a line has slope m, so we know the slope, but it passes through some other point that maybe isn't the intercept, the y-intercept. So I'm calling it x1, y1. Then the equation for the line is going to be y minus y1 equals m times x minus x1. Okay, so x and y are variables, and x1, y1 are the points that we know. Okay, so let's do an example with this one. So suppose that I have these 2 points here, so 5, 4, and -10, 12. So I don't know the slope So the very first thing I need to do is compute the slope. So y2, so negative 2 minus 4 over negative 10 minus 5. So this is going to be negative 6 over negative 15, which is a positive number, and they're also both divisible by 3, so it's going to be positive 2 over 5 is our slope. Now we can use either point. Okay, I'm going to use the 5, 4 one just because they're not negative, but it doesn't matter. Okay, so in point slope form, our equation is, so y minus the y1, which is a 4, equals 2/5 times x minus the x value, which is a 5. Okay, now this is an equation for the line. So if it just asks for the equation, you can stop at this point. Now, if you want it in slope-intercept form, what you can do is solve for y. Okay, so I'm just going to simplify. So I need to expand the 2/5 through. So I get 2/5 x minus 2/5 times 5 is just 2. And then I'm going to have to add 4 to both sides to get the y by itself. So it's going to be 2/5 x plus 2. So this would be the equation in slope-intercept form, which, like I said, if they don't ask for it, you don't really have to do that. Okay, maybe let's do one more here. So we have these 2 points, so 8, negative 4, and negative 2, negative 4. Again, neither of them are the intercept. So we want to find the slope. So I take, so the y value, one y value minus the other y value over x minus the other x. So here I have negative 4 plus 4 over negative 10. This is 0 over negative 10. So I get a slope of 0. Now, we said before, a slope of 0 means a horizontal line. But you can still use the point slope form to find the equation. Okay, so then we have equation. So you might know the equation right away, and then you don't have to do this. But I'm going to use, I don't know, let's use this point just to be different. Okay, so it's going to be y minus negative 4 is equal to 0 times x minus negative 2. Okay, so that would be an equation for the line, but obviously because of the 0 in particular, we really want to simplify this. So this is y plus 4. 0 times anything is just 0. Okay, so that's 0, which means that if I move the 4 to the other side, y should be negative 4. This is actually the equation for the horizontal line, and in fact it's in slope-intercept form, because you could think about it as 0 times x minus 4. So it's in slope-intercept form. It's just that the slope is 0. Okay, so a summary, we didn't do vertical lines, because when you have a vertical line, you actually can't use these methods to find the equation. Because the slope is undefined. Okay, so that's a problem because both of the methods use the slope. But if you have a vertical line, the equations are always x equals some number. So let's call it k, where k is a number. Okay, so they don't have, there's no slope, so there's no y value. So, summary, slope-intercept form looks like y equals mx plus b, where m is the slope and b is the y coordinate of the y-intercept. Okay, point slope form, y minus y1 is m times x minus x1. Again, m is the slope. And here, x1, y1 is a point on the line that you know. Standard form is a bit weird and not very useful, but we say that it's ax plus by equals c, where a, b, and c are integers usually. Okay, so it tells you nothing about the line really, but that's what it looks like. Now, if you take these two and you solve for y, it will put you into slope-intercept form. Okay, so you can always change into slope-intercept form, which is useful. Okay, so a horizontal line always looks like y equals, let's say, h. Okay, where h is actually the y-intercept, or the y-coordinate of the y-intercept. And here our slope is 0. Okay, so this technically is in slope-intercept form. Okay, and the vertical lines are always x equals k, where k is the x-intercept value. Okay, and m is undefined. Okay, so that's a very brief introduction into lines, how to find the equation of it specifically, which is what we're going to be using